Hi, everybody. My name is Andrea Afruni. I'm a PhD student at the University of Groningen in the Netherlands. And I'm very happy to be here today to show you our recent results that we have obtained together with Filippo Fraternali and Gabriele Pezzulli, and that we published just a couple of months ago. Results that regard the cool CGM of star-forming galaxies. So the focus of this work is the impact that galactic winds have on the CGM, which is something that we have discussed extensively at this conference, especially in the last week. And in particular, we try to answer the key question of what is the role of these galactic winds in the origin and the dynamics of the cool 10 to the 4 Kelvin gas in the halos of star-forming galaxies. So this has been done extensively using hydrodynamical simulations, but we try here to use a different approach, which is trying to reproduce the CGM using analytical prescriptions. So we built these semi-analytic parametric models where cool clouds of gas are ejected from the central galaxy, powered by the supernova explosions in the disk, and travel throughout the halos with their motion driven by the gravitational force and by the interaction with the hot corona, mainly the drag force that slows them down. So we model these clouds, and then we perform synthetic observations, tracing artificial line of sights, and then we compare the outputs of our models with real observational data. We used in particular a sample of around 40 star-forming galaxies, which have been selected by from the two surveys of COS-Halos and COS-GASS. So through the comparison between model and observations, we can actually try to constrain what values do we need for our free parameters in order to reproduce the observations. What are the best models that can reproduce the observations? So we did this comparison using a Bayesian analysis, and what we find is shown here in the slide. And briefly, what we find is that we need very massive clouds, and that these outflows need to be almost isotropic. And most importantly, these clouds need to be ejected with very large velocities, so with velocities that are larger than 500 kilometers per second. And we need mass loading factors, which I define as the ratio between the mass outflow rate and the star formation rate of the galaxies of the order of 10. So if we use these two values, we can calculate what is the kinetic power that is needed by these winds to reproduce the observations, and then we can compare this value, this kinetic power, with the power coming from the supernova explosions. Doing this comparison, we can constrain this efficiency, the supernova efficiency, which tells us how much of the energy available from the supernova is actually going into kinetic energy. And from theoretical studies, we expect this efficiency to be of the order of 10%, but we find that these outflows need actually an efficiency of 250%. So this value is extremely high, and also it's unphysical, because it means that these outflows need an amount of energy that is greater than the one available from the supernova explosions. So to conclude, we just found that these outflows have unphysical energy requirements to reproduce the observations, and therefore we can conclude that supernova-driven galactic winds are not a viable way to reproduce at least most of the cool circumgalactic gas in star-forming galaxies at low redshift. So if you're interested in a bit more details, you can go and check out our paper, or you can just drop me an email or send me a message on Slack. Thank you very much for your attention.